All right. Afternoon, guys. That person is not here, but we're gonna record it such that those who are not here can join. So basically, almost the end of what I need to teach, but as you know, I had to run off a little bit because of some emergency. Fortunately, we are far ahead in the syllabus. So the idea is to just do some practice work until I come back because the remaining topics that I have to teach, I want to do them face to face. I don't want to do them online. And so I sent some work just for practice. Um, just expose it to some other formats of questions, right? And this should enhance our understanding of the topics. And so we have to practice those questions. We start to go fully into our exam prep, and we basically focus exclusively on past paper questions. We've been actually doing past paper questions as we go, so nothing to lose really. So here is just to basically practice some other type of questions. The more questions you do, the wider variety of questions that you expose yourself to, it's a greater level of understanding of the topics. So I'm seeking to find exam level questions from other exam bodies, other syllabus like GCE and so on, and expose it to those questions. And then by the time you come back now to the CSEC questions, it should be smooth sailing. All right. So this is the algebra question really, this one on the screen. And it's mainly advanced level, but can be pre-maths level as well. And it says using a suitable substitution, we are to solve this. Now, once it says solve, it means that you have to find the unknown. Unknown is x. You need to find x. And it's saying using a suitable substitution. So what is that substitution? I think what the substitution I want us to make is to substitute for this and make a substitution related to that term. So it could be, for example, y equals 2x minus 3. If I kind of think ahead and realize that if you make that as a substitution, it should become y squared minus 4 over y squared minus 3 equals 0. Now, a cold gas, you have to bear with me, right? Kind of struggle with a cold as well. So now if I'm trying to solve this, I multiply through by y squared. I'm going to generate, sorry, y to the fourth power. So I don't want to do that. So a substitution I would prefer to make is y equals the squared term. All right, that's a substitution I would make. All right, so I think that would kind of make it simpler. You have to kind of do that because they don't tell you what substitution to make. They are telling you to make a substitution. This is not to say that the y equals 2x minus 3 would work, but I just feel that y equals 2x 3, y minus 2x minus 3 all squared would reach your solution quicker. Because I don't want to generate a y to the fourth or thing, right? So I'm going to make the substitution. Let y be equal to 2x minus 3 squared. And then this equation, let's go back for the blue now. So this equation would then become, right, is here. This equation would then become, it would become y, not y squared, just y minus 4 over y minus 3 equals 0. Then I would multiply 2 by y to get rid of this fraction, right? Expand out everything. You're trying to create a polynomial, right? So I multiply 2 by y now. So if I go now, and I multiply 2 by y, then this equation become y squared. Multiply this by the y, I'll get minus 3y. Multiply this by y, it will cancel this y and give me minus 4 equals 0. So you see, we get a nice, easy, straightforward quadratic to factorize equals 0. So it will y and y factored of this minus 4 is 1 and 4. The signs are different. Give it greater one, the minus. The greater product is with this one, give it minus. this one plus. So this one will give me y equals -1. This factor giving me y equals 4. We're ready to make back the substitution now. So we're going to replace this now with the y. That 2x minus 3 squared. So it means that on this one, we would have 2x minus 3 squared equals -1. And on here, we would have 2x minus 3 squared equals 4. Now, this one is not going to have any real solution because you see, we cannot find a real answer for the square root of -1. And I think this equation one real answer, so I'm going to say this one is not valid. All right. If the syllabus had complex numbers in it for pure maths, right, or even odd maths, but in the past, complex numbers used to be an odd maths, then you have to also give the complex number or the complex number or the unreal number, imaginary number solution that this should produce. But now I'm just going to say not valid because we're not dealing with imaginary numbers in this syllabus. I want to say this is not valid. But this now, when you square both sides, this become a plus or minus 2. All right. So the 2x minus 3, when you square with both sides, this will become a plus or minus 2. And you have to introduce the plus or the minus right there. Very important. All right. When you're trying to get all the solution, all the values. And then we're solving for the x. So what is it? It will be x equals, transpose this 3, we get a positive 3. So it will be 3 plus or minus 2. And then take this 2 and divide it on here. Divided by 2. And then now the two solution will be 1 with the plus and 1 with the minus. And so the x would be 3 plus 2 over 2 or 3 minus 2 over 2. So therefore x would be 5 over 2 or this would be 1 over 2. And that's your solution for this question. But to go to that, that's just an algebra question. Add mass level, pure maths will get something like this. But okay. Hello. I wonder if I know that understand. Hello?
Yes, sir.
Okay. All right. This one again can be add maths or pure maths. It says we have to solve this equation, this whole equation, and it wants to give answers between 0 and 1 into the degrees. So that's just in the first two quadrants. I don't want angles in those two quadrants. All right. So have an equation like this, what you have to do is really expand it out into separate terms. That's the first thing I would do. So we'll take this denominator and multiply it across here by the 3. So my first step, I have to expand it out into separate terms. And so I would get tan theta plus 2 sine theta equal, I'm going to take this now and multiply it by the 3. So it's going to be 3 times this tan theta. It's going to be 3 tan theta. And then 3 times this minus 2 theta becomes minus 6 sine theta. All right, and then let's consolidate now. So I'm going to take these terms and transpose them onto this side. We leave 0 on this side. So it will be 3 tan theta minus this tan theta gives me tan theta. It will be minus 6 tan theta, and then 2 more come over here to give me minus 8 sine theta. Minus 6 sine theta, and then minus another 2 sine theta is minus 8 sine theta. Alrighty. So I can divide this 2 by 2 and get 0 equals tan theta minus 4 sine theta. How do we proceed? I have to remember that this equals sine over cos. All right. And we can substitute this and make it sine over cos, or we can make a substitution for this instead. Let's see which one is better to do. All right. So Remember on the side here that tan theta is sine theta over cos theta. We can actually substitute for this sine theta and write the sine theta multiplied by the cos across here. And then you will get that sine theta is tan theta times cos theta. I'm just gonna make that substitution. Take this and replace sine theta here. And it's 4 of them we have. All right. So it would then be that 0 equals tan theta 4 of this minus 4 tan theta cos theta. Then I've created a situation now where I can factorize with tan theta. So 0 equals tan theta into 1 minus 4 cos theta. So that the tan theta equal to 0, this expression equal to 0. You only get 2 possibilities. It's tan theta equals 0, or from this one, it will be that cos theta equals a quarter. But I can see that. Just excuse the drafting and the pulling on the notes and stuff like that. I'm really struggling with that code here. But I understand that?
Yes, sir.
Alright, good. So when we reach a stage now, we need to draw a quadrant diagram. So the quadrant diagram for this one, where tan is positive, and the quadrant diagram for this one, where cos is positive. And remember, we're only working 0 to 180 degrees. So we only want the first 2 quadrants in our solution. So I want to cross these out because we're not using any of the angles down here. All right. Based on this, we're not using any angle down here. All right, so for this one, the principal angle alpha is 0, because tan to the minus 1 of 0 is 0. So this one, the alpha is 0 degrees. And we want your tan is positive. Treat 0 as positive. And that would be here. So remember the answer don't include 0 now, guys. Say greater than 0 and less than 90. So we're not including 0. All right. It would also be on this line, but the tan of 180 is also 0. You're not including 0. So this is actually not giving any solution that you wanted, because you would get that theta equals this quadrant. Let me change something, because I'm seeing that I'm getting 80 with the 0. So let me change something here. Erase these. Let me erase these, because I'm getting 180 minus 0, which puts me back on the. Let me mark these 2 quadrants as where tan is positive. And we'll do the same thing over here and just eliminate the answer that we don't want in the end. And then so over here, where cos is positive is here and there, but we're not going to take an angle in that one. But here for this one answer for this quadrant will be 0. And this quadrant will be 180 plus 0, 180 degrees plus alpha. This is 180 plus alpha, which is 0 degrees. And so the theta here is 0 degrees and 180 degrees. But these are not valid answers, because the question don't want those values. It wants greater than 0 and less than 180. So you don't want those answers. So these would not be valid answers, right? So these would not be valid answers, right here. So these would not be valid answers. So it looks like our only solution is going to come in from here. Here, we're going to use the principal angle alpha. It's cos to the minus 1 of a quarter. We're working that in degrees. Because we don't want this quadrant, which is 360 minus. This one is going to be out of it. So let me shield back down here. All right. So whatever this angle is, it's going to be our answer. All right. So let me get the calculator. Cos to the minus 1 of a quarter in degrees. One. So it's cos to the minus 1 of 0.25. That's 75.5 degrees. So that's 75.5 degrees. Right? And so theta would be that. What's this quadrantal low? This first quadrantal low. 25.5 degrees. And this would be our answer. I couldn't use this one down here, but I said I don't want anything in that range. That is the. But good at that. But is okay with that.
Yes, sir. Yes, sir.
All right, let's continue. They also told you to do this one, right? Number 3. These are some advanced questions. This paper is advanced level. Really. Remember, once it's advanced, it's also pure maths, but it's more at advanced level. It says a line with this equation and a curve with this equation. K is a constant. It says find the set of values of K for which the line and the curve have two distinct points of intersection. It means that when you try to solve the line and the curve simultaneously, you have 2 points of intersection. So it's like you have a curve and a line. And they intersect at 2 points. So you try to solve them simultaneously. The equation that they get is supposed to have 2 roots. That's what it is in. I'm sorry. So at intersection, this one kind of easy because you have y equals this and you have y equals that. So it means that we can equate those two things. All right, line and a curve. Y is the same on the line and the curve. So it's going to be that x squared plus kx plus 6 on the curve is equal to the y on the line is 3x plus k. So this is the equation that must have 2 distinct roots because there are 2 points of intersection. Well, let's put it in a standard form. A quadratic expression equals 0. Let's put it in that standard form. So that's the only x squared term in it. So that comes back x squared. Then this x comes over here, becomes a minus x minus 3x. So it becomes kx minus 3x. It really becomes k minus 3 times x. And then this is 6, and this k comes over here. So it then becomes 6 minus k. And that's all equal to 0. Then this expression is like you have a 1 in front of this. And this is a. The a equals 1, coefficient of that. The b is this expression. The b equals k minus 3. And the c is this. The c equals 6 minus k. And then this equation has 2 distinct roots, real and different roots. Put it in red. But this equation has real and distinct, meaning different, distinct roots. Because it has real and distinct roots, the discriminant of it, b squared minus 4ac, is greater than 0. And then this is what you're going to set up and solve. All right, so this is what we want to solve this. Set this up and solve it. All right. And so it says set of values of k, meaning some inequality you must get. You're trying to find a set of values of k. All right, so we're going to set this up now and solve it. This thing. So the b is this, k minus 3. So we're going to get k minus 3 squared minus 4 times a. The a is 1. Coefficient of x squared is 1. Times c. The c is this expression. 6 minus k is greater than 0. That's going to become a quadratic inequality. That's what it is, a quadratic inequality. So I'm going to expand it out into the standard form. Expand it out and set out into the standard form. So expanding this, it becomes k squared minus 6k plus 9. And then this one is negative 4 times this. So that is minus 24. And negative 4 times negative k becomes a positive 4k That's all greater than 0. Let's consolidate. So it's k squared from this one. And this minus 6k and this 4k is minus 2k. And then this is 9 minus 24. How much is that? How much is 9 minus 24? How much is 9 minus? How much is 24 minus 9? All right, nobody
15.
else. Minus 15 is greater than 0. Minus 15 is greater than 0. And then now this can be factorized 5 and 3. Factorize this into 5 and 3. Difference is the middle term of 2. It's factorized easily. So it becomes k, 5 and 3. Signs are different. Give a greater product, the minus. So greater product gonna be the near one for the 5. So to make that negative, make this positive. And that's all greater than 0. So if we're to sketch the graph related to this inequality, it will be a smile. This smile is relating to this inequality, not the original curve up here. All right. So the axis is the k-axis, not x-axis, k. And these two factors giving us two roots. This factor giving us a root of positive 5 over here. And this factor giving us a root of negative 3 right here. And then this greater than 0 means that you want the part of the graph that is above the horizontal axis, which are obtained by k value to the right of this 5 and to the left of this negative 3. I put 1 there, supposed to be 3. And nobody said anything. All right. So on this side, it will be that the k is greater than 5. And on this end, it will be that the k is less than negative 3. This guy does a solution. Right? The solution is k less than negative 3 or k greater than 5 outside those two critical values. And that is the answer right there, the set of values of k. But I write that. It's an advanced level question again. But go to that.
Yes, sir.
All right, I did not ask you to do this question. I know. Yeah, I asked you to do this one. I think I asked you to do this one. Yeah, I asked you to do this one. This one says a curve is such that dy by dx is equal to this. And this is a point lying on the curve. All right. It says a point is moving along the curve. And at A, at the point A, where x equals 1 and y equals minus 3, the y coordinate at the point is increasing at 3 units per second. Now, this that they just gave us is the dy by dt. That's what that is. Dy by dt. So it says dy by dt is equal to 3 when x equals minus 1 right here. X equals 1 not minus 1. X equals 1. And y equals minus 3 right here. It's at this point. It says, find the rate of increase of the x coordinate. This is asking us. This thing is asking us for dx by dt at the same point at the point A, 1 minus 3. That's what it's asking us to find. All right. So to find this, we're going to have to connect the rates of change that we have. We have these two rates of change, this one and this one. We're going to have to connect them to find the dx by dt. Let's do it. So the dx by dt that we're trying to find is a product of two rates of change using the chain rule. dx goes on top of the first one. dt goes on the bottom of the second one. And the third variable is y, goes here and there. So notice that we have dy by dx, but they're asking us for dx by dy here. So this by dy is just a reciprocal of this and that. That's all that it is. And the dy by dt is this 3 out here. And so this thing, dx by dt, becomes equal to the reciprocal of this, which is 3x minus 2 cubed over 6 times, and this is 3. That's it. Remember, it is at this point where x equals 1. So we need to put x equals 1 right here. So we're trying to find that where x equals 1 at the point E. So we're going to put 1 in here so to get that final rate. And so the dx by dt at that point becomes, put the 1 in here, it becomes 3 times 1 is 3 minus 2 cubed over 6 times 3. It works out to be what now? This works out to be 1 because this 3 minus 2 is 1, and we raise 1 to the power 3, get 1. 1 cubed is 1. So, and then this 3 cancels into this 2 times, and this becomes 1. The final answer is a half, 1 over 2. So this becomes 1 over 2 units per second. That is it, half, 0.5. But okay with that? Body good?
Yes, sir.
Hello? All right. Next part now says find the equation of a curve. To find the equation of a curve, what we're going to have to do is integrate that and use this point, find the constant, or we can integrate it straight from x to y, starting at 1 x value to -3. You can do it that way. All right, so let me write this out first and copy it down. That the dy by dx is 6 over, let me write it like this. The power function is 6 times 3x minus 2 to the minus 3. Take this up and bring it up, I'll put the minus 4 on it. So this is what we actually have solving. Copy it down. That's what we have. Write it a power function down here. All right. It means then that this side is equal to, going to multiply this over here and integrate both sides. So like you have dy equals 6 into 3x minus 2 to the minus 3, and the dx is multiplied over here. So we have dx. And then what's happening is that I want to integrate both sides, integrate this side and integrate that side. But to get the final solution, remember we're starting from the point 1, -3. All right, from 1, -3, right? So on the x side, starting from an x value of 1, I'm going up to an x value of a general point of x. Then on the y side, we're starting from an x value of -3, from a y value of -3, sorry. We're going up to a general point where the y value is y. So that's going to give you your equation straight without the need to calculate a c. Now the integral of dy It's like integrating 1 dy. So it just becomes y between the limits of -3 and y equals over here now. Now, this 6 is a multiplying constant, so it can come out to the front. We can leave it there. It's a multiplying constant. We're going to add 1 to this power, get -2. So let me leave it. So we're going to put 6 into 3x minus 2. Add 1 to this power and get -2. Divide by that new power of -2. But then also divide by the differential of what's in the bracket. When you differentiate the bracket term, you're going to get a 3. You also have to divide by that because it's a constant. That's going between the limits of 1 and x. 1 and x. That's going to give us the equation straight. All right. So over here, we're going to plug in the y first and get y minus, plug in the -3 to get y minus a -3 on the right side equals. Here now, this is actually -6. You have 6 here, so you can put a -1 out the bracket because 6 divided by -6 is -1. Then put -1 outside the bracket. I'm going to put in the values first. And this negative power means a reciprocal. So remember, these gone, you know. So I'm now going to just put this as 1 over 3x minus 2 squared. And we're going between x and 1. And I'm ready to plug in the values now. So this side becomes y plus 3 equals -1 into. Plug in the x here so we can get by the same thing, right? 1 over 3x minus 1 minus 2 squared minus. Plug in this 1 right here, so now you get 1. Because when you plug in this 1 right here, where the x is, it's going to become 3 minus 2 is 1. 1 squared is still 1. 1 divided by 1 is 1. So we're going to get -1. And basically, that's the equation, you know. Right? You can apply this -1 on these two. So, and then take this 3 and carry it over. So let me read it first. So it's y plus 3 equals, apply this -1. So -1 times -1 is a +1. And -1 times this is going to give me -1 over 3x minus 2 squared. And this 3 now comes over and become a -3. So we're going to actually become y equals -2. 1 minus 3 is -2. Minus again this expression. 1 over 3x minus 2 squared. That's the equation right there. Everybody good with that? You want to find the way you find the C
Yes, sir.
first, point and find the C, that's fine. Right? To the right, you're gonna get the same equation. All right, that is that. Okay, moving right along. Related to this one, no. Function not on the ADMAT syllabus anymore. It's on the PureMath syllabus. So they will not ask you to do this one. This is almost CSEC level. All right, they'll ask you to do this one. Yes. This one says, those are 3 points on a circle, on the circumference of a circle, you must find the equation of a circle. So think of it this way. If you have done a question like this before, if you have 3 points on a circumference of a circle, right? What you're gonna need is 2 perpendicular bisectors. Like this is A, this is B, and this is C. I'm just randomly putting down 3 points. But maybe kind of easy, you know, to look at the values because standards have the same y value. So same y value, so that make it kind of easy. And this and this have the same x value. Okay, so it's easier than I thought. So we can actually use it. We can use the actual coordinates and figure out where the perpendicular bisectors. All right. Because to do this, generally speaking, what you would have to do is, guys, if you have 3 points on a circle, right? And trying to find the equation of that circle, you have to find a chord, and you find the perpendicular bisector of that chord. I try to find where the center is. So you have to find the perpendicular bisector of that chord. Then the chord between these two, let me draw it out from color. So join these two with another chord, and do the purple bisector of that one as well. And move that back one in purple right here. So you have to find those two perpendicular bisectors of those two chords, and then where they intersect, solve them simultaneously to find where they intersect with the center. And after I find the center right here by solving these two perpendicular bisectors simultaneously, you know, find the distance between the center and any one of the 3 points, right? Find this distance, for example, that to be a radius. And when you know your center and your radius, then you can write the equation. So that's how you would basically do it. But these points appear to be friendly points, right? Because these two have the same x value, right? So it means that they are just vertically above each other, and then these two have the same y value. So it look like we'll be able to work out those chords kind of quickly. And let me put on relatively those two first. Same x value. So like me have A here, so A1 and B up here, so right, relative position. So we have the same x value. So this is 7, 1, that's A. This is 7, 9, that's B. 7, 9. So it's both of them are on the same line, x equals 7, like that. All right. Then this point is 1, 9. 1, 9. So that the same y value as this one, which is 1. So it's more to the left. So I'm gonna move this over. So we can get a true indicator of where the points are. Put this on this side, the B, put it on this side again of the point. So 1, 9 would be same y value as this one. 1, 9 should be something. So it would be at coordinate of one, x coordinate of 1. So it would be maybe here. C. So C 1, 9. All right. So these are 3 points on the circle. So what we do, we know that the perpendicular bisectors intersect. All right. So we want to use perpendicular bisector of these two horizontal and these two. Make it make sense, right? All right. So this will be one chord. This will be one chord. I want to go halfway between this and this. That is at 5, to go halfway between a y value of 9 and a y value of 1. You average them. That's going to be 5. So y equals 5. Y equals 5 is the perpendicular bisector of this one. Y equals 5 horizontally. And then no, these two. Let me put this one in purple as well. That chord is horizontal from 1 to 7. So the perpendicular bisector is halfway between 1 and 7. So halfway between 1 and 7, you average them. Average of 1 and 7 is 4. All right, average of 1 and 7 is 4. Add them and divide by 2. So this line will be x equals 4. So these two perpendicular bisectors will intersect right here. Where the x value is 4 and the y value is 5. So this point then is a point 4, 5. And that will be the center of your circle. But I can appreciate that. So we can sketch out a circle too. So it's like a circle like this. But I can appreciate that.
Yes, sir.
All right. Something like that, right? Not exact. And then now the distance from this center. Huh? Yes. A question you have?
No, sir. Sorry, sir.
Okay. All right. Then now the distance from this point to, like, for example, the C is a radius, or to the E. It doesn't matter. Any one of them you measure the distance to is a radius. So the radius would be equal to, for example, let's call the center point O. If center point is O, then the radius, for example, will be OC. And that will be equal to the square root, working it out. That will be the square root of the difference in the x value, which is 4 minus 3. 4 minus 1, sorry. 4 minus 1 squared, and 9 minus 5. 9 minus 5 squared. All right, so you see that this becomes a 3, 4, 5 triangle. Oh man, press the wrong thing, guys. Press the wrong thing. Press the wrong thing on this device. Right. So it will be R equal to square root. This becomes 3 squared plus 4 squared, which works out to be 5, right? So the radius is 5. R is 5. Because this becomes 16 plus 9. 16 and 9 is 25. So it's about 3, 4, 5, pi to 1 triple. Then you're good to go. So the equation of a circle now. Remember, it's x minus a squared plus y minus b squared equals the radius squared. What is A and B? A and B is the coordinates of the center. So this is the AB right here. Coordinates of the center of the circle, and the work out radius as 5. So the equation became something easy. It becomes x minus 4 squared plus y minus 5 squared equals 5 squared, for the radius is 5. Excuse me, guys. Excuse me, please. Can't control this cough. Throat is groggy. All right, that is it. Nice and easy, like that. And I could accompany your solution with the sketch, because it helps. You can actually visualize it. So I'd accompany my solution with that sketch to show it. All right, but good.
Yes, sir.
It was important for us to recognize that these are the same x value. All right, so they're the same vertical line. These are the same y value. So they're the same horizontal line. Makes it easier to deduce where the center is. All right, so that is that. So much space to give for it. This one now says find the equation to the of the tangent to the circle at B. And where did we put B? We put B over here. I want the tangent over this. Let's sketch it again. Let's sketch it up here. So say you have a circle, and the point B is somewhere up here, and we want to find this tangent line T. T for tangent. Remember, when you're working with circles, the normal is your best friend. So when this point again is 4, 5. The normal is your best friend. This is a normal. The normal helps you to find a tangent. The point B right here. What is it again? B is the 0.79. All right. So it's because I know this point, I know the center point, it's easy to find the greater of this normal. And that's how we start. All right. That's how we start. So the greater of the normal, MN, meaning normal, is the difference in whatever difference is between these 2 points. So it's this y value minus this y value. That's 9 minus 5 divided by this x value minus this x value, which is 7 minus 3. So the 9 minus 5 is 4 over 7 minus 3 is also 4. That's right. And that's 7 minus 3, 7 minus 4 moment. 7 minus 4 moment. What happened to me? 7 minus 4. I'm calculating the answer. So it's 9 minus 5 up here, and 7 minus 4. The All right, so that is, it says over 3. The grade of the normal is over 3. It means then that the grade of a tangent is -1 over the grade of a normal for the perpendicular. You obtain that by flipping this gradient and changing the sign, becoming -3 over 4. And to get the equation using this gradient of the normal, of the tangent, sorry, and this point is a point gradient form for the equation of the tangent. So you can see something like this. The tangent is y minus the y value at the point, which is 9, equals the grade of a tangent is this, -3 over 4 into x minus the x value at the point at the tangent point is 7. That's going to give you an equation. Simplify this easily, or can we step this 4 and multiply it across here? And we will get 4y minus 36 equals, take this -3 and multiply it inside the bracket. It will be -3 times the x first is -3x. Then -3 times -7 is plus 21. We can transpose this 36 over there and add it. So we're going to get 4y equals -3x. When this comes over here, add to 21, it becomes 57. 57. That's the answer. That's the answer right here. You want to divide through by the 4 and put y as a subject, no problem. But that is it. But I go to that. What is a typical ADMATS question? ADMATS question could definitely get a question set out exactly like this on their paper. But okay, pure maths could get it, you know. Remember circle coordinate geometry. The same for ADMATS and pure maths. So yeah, pure maths students could get this as well. All right. It is it. All right. Did I tell you to do this one? Did I tell you to do this one? Yes. I told you to do this one, but it's an APGP. Statistics and cost. It says the first term of a progression is cost, where the angle is between 0 and 90. So we say positive, right? Cost of an angle between 0 and 90. This is pi by 2 in 90 degrees. So it means that we're working in this quadrant right here, where all 3 equations are positive in the first quadrant. All right. So it said the first term is cos theta. It says for the case where the progression is geometric and has a sum to infinity of 1 over cos theta, show that the second term is this. All right. All right. So in the first case, in this question, what they're basically saying is a GP. The first term is cos theta. We don't know the common ratio. We don't know the common ratio. We don't know it. They don't tell us a common ratio. But the sum to infinity is this. Sum to infinity is 1 over cos theta. That's what they're telling us. What's the formula for the sum over infinity? It is 1 over a minus 1 over r, 1 minus r. A over 1 minus r. Right? So we can say using this is all we have to use this information. Tell us what that is. And we know that the sum to infinity, we can say no. Sum to infinity is really a over 1 minus r. Minus the r we don't know. All right. And I want us to tell them what the second term is. Can find the r first. I will know the a is cos theta right here. And the sum is this. So can basically put in what we know, and then r will be what we don't know. This second term that we're trying to find is actually AR, right? The second term is AR. That's what this is, AR. So it's almost like you're trying to find AR. Right? The second term is A times R. Right? The first term is A, second term is AR, third term is AR squared, and so on. So you're trying to find AR. So whichever you want to do it, you want to find the R first, no problem. Well, let's put in what we know, and then we're trying to find the R. R is what we don't know. So the sum to infinity is this expression. So you want to put that 1 over cos theta is equal to A is cos theta. So that is equal to cos theta over 1 minus R. I'm trying to find this R. We're trying to solve this for R. So I want to take this diameter, multiply it up here, and take this cos theta, multiply it up there. So it's going to work out that we get 1 minus R equals cos squared theta. Cross multiply. And if we take this R and bring it over, the aspect carry it over. It's going to be that we get that the R is equal to 1 minus cos squared theta. We must know that 1 minus cos squared theta is actually sine squared theta. So this concludes that R is equal to sine squared theta. Therefore, the second term is A times the R. See, the R is sine squared. You can see it. So you can say, therefore, therefore, the second term, AR, becomes the A is cos theta, and the R is sine squared theta. And therefore, show that was shown. Very good at that. But okay?
Yes, sir.
All right. Next part now says, find the sum of the first 12 terms when the theta is pi by 3. Giving your answer to 4 decimal place. Let's go again. Find the sum of the first 12 terms. Or it's the same series, right? It's the same series basically, so nothing has changed. So basically telling us is that the angle is pi by 3. All right? It's pi by 3. So by telling us what the angle is, we are supposed to know what the values are. Like, for example, supposed to know what the R is, what the A is, and we're going to find the sum of the 12 terms. All right? That's what this is about. So for this one now, the theta is pi by 3. So pi by 3 is really 60 degrees. And remember, it is really 60 degrees. All right? So if that is 60 degrees, then the A, which is cos theta, becomes the cos of pi by 3. Cos of pi by 3 is a half. Cos of 60 degrees is a half. All right? And then the R now is this, sine squared. And the R is sine squared theta, which becomes sine of pi by 3 r squared. So the sine of pi by 3 is root 3 over 2. So this becomes R equals root 3 over 2 squared, which then becomes 3 over 4. All right, 3 over 4. And you want the sum to what 12 terms. So the sum to 12 terms, sum of an AP, sum of an GP, sorry, sum 12 terms, the one man on the sum to n terms. It's A into 1 minus R to the n over 1 minus R. All right. Let me see if that was given on the formula sheet for the sales. Let's see. It's in the formula sheet for the sales exam. Let's see. Formula sheet is not here. I guess they will put it in a formula booklet. Some papers they put the formula sheet on the paper, but that is the formula for that though. Right, but these things will be on your formula sheet in your exam. And I can't read them off my head because that's how we used to do maths in the past. We used to just learn everything. So that is basically your formula. You drop in your values in there. That's it. All right. So this becomes the A is a half. We can actually put decimals in, okay? I say them say they ask us to use 4 significant figures. So for this one, we can use 0.5. And for this, we can use 0.75. And use those instead. So the A is 0.5. So that's 0.5 into 1 minus the R, Let me use a different color. Work with the proof. R is 0.75. 0.75 raised to the n is 12. Sum to 12 terms as O. Sum to 12 terms, put the 12 here. So over 1 minus R, and R is 0.75. And you put this in the calculator and work it out, and you get the sum to 12 terms. And let me get the calculator. This again is an advanced level work. Advanced students will get a question like this for sure. And so putting this in the calculator, this expression right here. It's a fraction 0.5 times bracket 1 minus 0.75 raised to the power of 12. Close that bracket. And if we did that over 1 minus 0.75. And it says what? 4 significant figures. So the first significant figure is the 1. Second significant figure is the 9. And the 3. So the fourth significant figure is a 6. And this 6 is supposed to correct that fourth significant figure. I'm going to turn it into 7. So it becomes 7. That's fourth significant figure. That's the answer right there. Want to go to that?
Yes, sir.
All right. That question will do. Next one says, part B says, for the case where the progression is arithmetic, right? The first 2 terms are given as this and this, right? All right. Find the 8th first. Find the 85th term when that is pi by 3 again. Let's go again. In the case where the progression is arithmetic, and the first 2 terms are again this and this. So you have to subtract them to get the common difference in the guys. You want the D. All right. Let's go again. The A again is the same cos theta. Cos of pi by 3 again, which is still 0.5. We didn't work out the second term, but it's easy because we know the R, right? We know the R was this. So again, so the second term, which is A plus D now. This is the second term, A plus D. So the A plus D second term will be equal to cos of pi by 3 times sine squared of pi by 3. You can literally use the calculator. I wrote this out too, you know. But it will basically be remember the sine squared was the R, right? Sine squared was the R. Let me see. Yes, the sine squared was the R. So it's basically the A times the R that we had before. All right. So the A was 0.5. 0.5 times the R was 0.75. R was 0.75 right here. All right. So the second term is 0.75. We didn't record the second term in the first part. So the A plus D here would be 0.5 times 0.75, which is 0.325. All right. So the D would be this minus that, common difference. So the D, so therefore, the D in this AP would be 0.325. It's the second term minus the first term of 0.5. All right, so we'll subtract 0.5 over here. So the D is actually a negative 0.125. And you're asked to find the 85th term. The 85th term, the 85th term. And the sum to 85 term is A plus N minus 1, 84D. That's the 85th term. A plus N minus 1. N minus 1 becomes 84. That's the 85th term. So put in the values now, nice and easy. The A is 0.5 plus 84 times the D, which is negative. Right, this better, Mr. Shaw. Negative, this is the D. Negative 0.125. Let me calculate and get the answer. So this is 0.5 plus 84 times a negative. Let's put a minus here. Let's put a minus here, so because it becomes a minus. It becomes a minus 84 times the value of 0.125. We get negative 10. Negative 10 is the answer. What good at that? What good at that?
Yes, sir.
Did I ask her to do any other question on this paper? Did I ask for this one? Yes. That's a circular measures. So yes, I'm gonna continue giving you some of these questions to do, you know, to have to improve the maths. And then we'll get back to the regular, easy, basic C-set advanced question, then no problem. Right, these questions make you really learn something. All right. It says the diagram shows a sector ABC. So that's a sector of a circle ABC, right? That's a sector. Which is part of a circle of radius R. So the radius of that sector is R, is A, sorry, radius is A. It says the point D and E lie on AB and AC respectively, and are such that AD equals AE equals KA. So this is KA and this is KA. Now naturally K is some fraction, right? Because the full length is A. So this is a fraction of A. So the K is some fraction. See here, K is less than 1. This kind of makes sense. All right. And it says now, the line DE divides the sector into two regions, which are, let's go again. The line DE divides the sector into two regions, which are equal in area. So it means that this area and this area is the same. That's what it means. Those two areas are equal. I'll put another way. The area of this triangle becomes half the area of the sector. All right, that's what it means. All right, it says for a case where this angle is pi by 6, meaning pi by 6 radians, 30 degrees, pi by 6 radians. Find K for significant figures. You really have to just put in information that they give you. Right? We basically say that this area is this area the same. I'll put another way. If these two areas are the same, then this triangle is half the area of the whole sector. But can I say that? Based on information. But I say that if this area and this area is the same, right? It means that the area of this triangle becomes half the area of the whole sector. That's what it means. That's the approach you can use. Because I won't bother waste time finding this area to show that they're equal. If this area and this area is the same, then the area of this triangle is half of the whole thing. I'm going to say it that way. The area of the triangle is half the area of the sector. And this angle is pi by, this angle they say is pi by much now? Pi by 6. So this area is pi by 6 in the first case. And when you know two sides of a triangle with two sides, an angle between, the area of that triangle becomes half the product of the two sides and the sine of the angle between them. Easy as that. So let's make that approach. The area of the triangle is half the area of the sector because two areas are the same, they divide equally. Here the triangle is half the area of the sector. Now the area of the triangle is half the product of the two sides, that's KA times KA. So that's KA squared times the sine of the angle between them. Sine of the angle between them is pi by 6. pi by 6 is 30 degrees. So it's going to work out to a half. Pi by 6. And that's equal to the area of the sector. Half the area of the sector. Now, half the area of the sector. What's the area of a sector? Half r squared theta. So the area of the sector is half the whole radius squared. That is this a squared. Times the angle half r squared theta. The angle is pi by 6. And that's the equation the solving for this k. But I can say that. But I go to that.
Yes, sir.
All right. So we're solving this for k. Now what's going to happen firstly? I can cancel out some stuff. This a squared that we're getting from this, we're going to cancel this a squared. So the a squared I'm gone, right? Then, for example, now this half, we'll cancel this half. And then the sine of pi by 6, sine of 30 degrees a half again. So then this half cancels this half. And then you have no k squared. So really and truly not the k squared. So God just keep us the half. Just this thing around and just the a gone. The a squared cancel with this a squared. So we still have k squared left. So it means that k squared is equal to pi by 6. That's what remains. Can you see that, guys? What's all those cancellation? We'll go through again. We'll go through cancellation again. Surely. Look again. All right, let's go step by step. So this half cancels this half. Oh, this is a sine of 30 degrees. That's a half, you know. This is actually a half. Sine of pi by 6. Pi by 6 is 30 degrees. That's a half again. So this half cancels this half. And then now, inside you're going to have a squared. Canceling this a squared. So I can cross out this a and cross out that a squared. So left with k squared equals pi by 6. That's what we're left with. Nice and easy. So k squared equals pi by 6. And I said that the k is a fraction. It's positive because there are dimensions. They're not going to give it a negative value, right? So the k is going to be square root of pi by 6. I'm going to write that out. It's a positive value because it is a fraction of a length. It's a length. So you can't give it no negative in this case, all right? So I wanted to 4 significant figures. Let's get a calculator again and work it. That's what we get. These are questions we need to practice from and improve after they get good. So it's a square root of a fraction pi over 6. 4 significant figures give me 0.7236. But the 0 coming after the 6 won't change that 6. Leaves it at 6. That's your 4 significant figures. Right? The first significant figure is the 7. First 1 0 value from left to right. That is the answer right there. But good at that? But okay?
Yes, sir.
That's easy. All right, let's the next part B. Part B says, for the general case in which the angle is theta radian, so we don't know the angle now. Theta between 0 and 90 degrees. This is 90 degrees. It is given that theta over sine theta is greater than 1. Don't know why that is. It says, find the set of possible values of k. Find the set of possible values of k, and they're telling us that theta over that is greater than 1. So let's see what I want us to do. All right, for the general case, where the angle is phi is thing there, is theta radian, we're still gonna go back. The one possible value of k, and this is the only thing that introduced to us with an inequality. All right. And if this angle, if theta between this angle, then this can also be multiplied across here, such that theta is greater than sine theta. And because it means that sine theta is positive because the angle is only between 0 and pi by 2. So this inequality is positive and this positive. So we can multiply this across here without no positive. And so theta will be greater than sine theta. So I don't know why we're going to need that, but let's go and see what we have. Let's see what we have. Let's put in information and so we can generate. This must mean something. This is what going to give us our set of values of K. Set of values usually mean they want an inequality. All right. So I'm going to go back to the information that they gave us, which is basically this. You have a triangle is half the other sector, but this time we'll put in just expressions. So let's go. So going back to the area of the triangle is half the area of the sector. Starting back there. The area of the triangle again is half the KA squared and the sine of theta now. I remember they said it was the general case in sine of theta. And that is now equal to half the area of the sector. And the area of the sector is half R squared, but the R is A. Half the R is A. Half R squared. So it's A squared times theta. All right? That's what it is. I see where we're going. So they give us this inequality. So we can actually form that fraction and put it greater than 0 by dividing. So let's cancel it again. Let's cancel it again. So the A squared can cancel again. Let's cancel it again. So this A squared will cancel this A on the square there again. This half will cancel this first half right here. So let's see what we have. We're therefore going to have K squared sine theta. K squared sine theta is going to be equal to half theta. Half theta. We can take this and multiply it up here. This 2. And so we would get 2K squared sine theta is equal to theta. But they tell us something here. Theta over sine theta is greater than 1. So to generate that, I'm going to divide by this sine theta and get 2K squared is equal to theta over sine theta. And this is greater than 1. What they told us. Right? This thing that they told us is greater than 1. So if this equal this, and this greater than 1, it means that this greater than 1 as well. So based on that information, you can say therefore 2K squared is greater than 1. So K squared is greater than a half. So K squared is greater than a half. We're going to solve this. That's like a quadratic inequality, you know, guys. That's like a quadratic inequality. You can set up like this. Let me set up like this for you. Let me set up like this. Let me set up like so something that we can factorize. Carry over back the 1 and put 2K squared minus 1 is greater than 0. If we treat this like the difference of 2 squares, right? This can be written as square root of 2K all squared minus 1 is greater than 0. So this should factorize into square root of 2K square root of 2K 1 minus plus greater than 0. If you think of it as a quadratic in K, 2 factors we get it. One that we get it from this is 1 over root 2 right here. 1 over root 2. And this factor given me minus 1 over root 2. And this 1 over root 2. And you want where it's greater than 0. So it means then that you want up here and up here to the right of this root and to the left of that one. So the solution then down here will be that the K is less than this value. Or the k will be greater than this value. But let's look at what they said about the k, for the negative or positive. We say k negative enough, so that's not a valid answer. But the k negative, right? K cannot be negative. Right? Based on the information, the k is less than 1, you know, but the k are negative because basically a factor of a length. So the k are negative. So the k then, this is the only solution down here. The k has to be greater than 1 over root 2, but less than 1. So the k is greater than 1 over root 2. It also must satisfy this original condition that they gave us. That is also less than 1. Right? So less than 1. So if you write that now, you put the k greater than but less than 1. So you write it like so, the k is less than 1, greater than this value, 1 over root 2. This one is not valid because k can negative. Not valid. And this is the answer right here. That's the range of values of k. That's a nice question. But good at that. But okay.
Yes, sir.
All right. But I've gotten it from you too, you know, remembering that if you have this, you're actually going to get k as 2 roots. K equals plus or minus 1 over root 2 as the 2 roots. It's greater than 0. Greater than means that you're going to get a small graph because the k is positive. And want the part above the x-axis. And these will be your 2 critical values that I have down here. That will show you in the factor form still, because you know, more familiar with that. But that is it. All right, that was a nice question. Did I tell you to the number 11? I doubt it. Did I tell you to the number 11? A couple of pure maths, a couple of paper from on the other paper to the pure now. No other paper I gave. Did I tell you to the number 11? Let me see. Yes, I said number 10 and number 11. I really want you to clearly the number 11 still, because I think we can maybe tackle it. Number 11 was the last one I told you today. All right, right here. Let us see. My 11 looks like a nice question to do. All right, let's go. So this question gives us this weird looking function. This weird looking function here. Right, give us a curve. And it tells us that this is the equation of it. Eh? It's a power function like that. It says the curve crosses the x-axis at A. We know that on the x-axis, what do we know? Y value is 0 at A. If we don't know anything else, we know that right here, the y value is 0. So to find the coordinates of A, we want to put the y equals 0. So you're going to put in this equals 0 and solve it. All right. So on the x-axis, y equals 0. So you put in this equals 0. So if this equals 0, the 9 is not 0. So it means that it is a bracketed term that must be 0, but everybody can see that. All right. So you're really then solving x to the minus half minus 4 times x to the minus 3 over 2 equals 0. That's what you're solving. Now, generally speaking, we don't work with negative power. Don't practice to work with negative powers. All right. Don't practice to work with negative powers. So the first thing I'm going to do with this one is put it as 1 over the square root of x. And I can take this and transpose it, make it equal to 4 over the square root of x. And you have a cube on it. So the square root of x cube. That's what the equation is. But I can appreciate that. But go to that.
Yes, sir.
And then to get rid of those square root, what we can do is square both sides, right? Square this side and square that side to get rid of the square root. So we square both sides. So you don't have a lot of space. So I expect to finish this quickly. We square both sides, you're going to get 1 over x equals 16 over x cubed. 1 over x equals 16 over x cubed. All right, then if I take this x cubed and multiply it up here, I'm going to get that x squared equals 16, which therefore means that the x is equal to plus or minus 4. But right here, it's clearly not minus 4. So it must be a positive 4. So let me shift this over. At a, the x is equal to 4. Clearly not a minus. All right, so at a, the x is equal to 4. It means that a is the point 40. A is the point 40. That is it. But I go with that. X is equal to 4. If I can test in this, can test it and plug in a 4 in that expression and see if it work out to be 0. Let's see. Let's see. Let's see if we get it. Let's just see. Just to be sure. Let's put a 4 in this expression where the x is, right? Right, but this whole expression, I put a 4 there. It's supposed to work out to be 0. So it's 9. 9 immaterial because it's this part that's going to be working out to 0. All right, so let's just put it in here. So it's going to be 4 raised to the power. And that power is a fraction. It's a negative 0.5. Negative half same as 0.5, right? Minus 4 times 4. No, this power is 1.5. 3 over 2 is 1.5. So it's 4 to the power of negative 1.5. Voila, we get 0. So you know the answer, right? Beautiful. All right, so that is it. You want nice. And then say no, find the equation of a tangent at A. Find the equation of a tangent at A. So know the coordinates of A. So to find the tangent at A, we need the gradient of a tangent at A. The gradient of a tangent at A is the gradient of a curve at A. Let's write it out. The gradient of a tangent is dy by dx on the curve. And at A, the x is equal to 4. So we're working out. So we're working out dy by dx to get the gradient of a tangent at x equals 4. So we're going to differentiate this thing. All right. All right, let's go. So the gradient of a tangent becomes differentiated first. 9 into, you differentiate this expression becomes minus half x minus half x. When you subtract 1 from this minus, that become minus 3 over 2 to the minus 3 over 2. And then we differentiate this one now. You multiply by this minus 3 over 2 times 4, you get a positive. So minus 4 times minus 3 over 2. This goes 2 times 3 is 6. The negatives can be a positive. I'm getting 6. 6. I got as 1.5. The 1.5, the 3 over 4 is actually 1.5. So I'm getting a positive 6. Getting plus 6. X and then this now we subtract 1 from this power. So like you have minus 3 over 2, we're subtracting 1. Now this one is same as 2 over 2. So it actually become minus 5 over 2 is the new power. So you get minus 5 over 2. And you're doing that at x equals 4. And so the gradient of a tangent is, well, I can plug in 4 in this and this and I work it out. But we know that this is the square root of 4, and that's the square root of 4 for those negative powers. So you get 9 into minus half the square root of 4 is 2, so it actually becomes 2 to the minus 3. We get 2 to the minus 3, and then plus 6, and then again the square root of the 4 part here, so it's 2, so you get 2 to the minus 5. I can put that in the calculator and see what that is. Keep it simple. So we're going to get 9 bracket. This is 0.25 right here. Minus 0.25 times, this is 2 to the minus 3, 2 to the power of minus 3. And then we are adding 6 times 2 to the power of minus 5. And then we're closing that bracket. And we get that value. Let's see what's the fraction. Get a fraction, must get a fraction. The work actually becomes this 45 over 32. So the grades of a tangent is 45 over 32. Grades of a tangent is 45 over 32. All right, or 1.4 something. The grades of a tangent. And then tangent, no, remember it passes through this 0.40. Right? So the tangent is y minus the y value at the point is 0 equals the grade of a tangent is this 45 over 32 into x minus the x value at the point is 4. And so it's y equals 45 over, sorry about that, that's 45 over 32x. And then this times this is what? That's 8 minus 45 over 8. That's the equation right there. Better go to that.
Yes, sir.
That's the equation of that tangent. And I answer the question. This one says no. Find the x coordinate at the maximum point. Now at the maximum point, dy by dx is 0. And this expression in is dy by dx, this. Dy by dx, right? So I'm going to copy it out. I'm not going to calculate it again. You know. This inside is dy by dx, this right here. I'll put this equals 0. All right, copy this. And paste it down here. This is dy by dx. And put that equals 0 to solve it. So basically solving that. All right, so when 2 marks for it, so you say they do expect a lot of work, guys. See that? Find the x coordinate. All right, so you find what x is right here. So find x coordinate at the maximum point. You put in this equal. So this 9 gone. All right, that 9 gone because you put in this equals 0, this 9 is gonna be gone. Only what's inside is gonna be 0. So I'm gonna cross it out in red. This 9 gone. All right, and then we can multiply 2 by this 2, and it's gonna become 12. Let me write what this is. Write what this is. We're trying to find x. I want to put 1 on one side again. Or we can put this on the right side, make it positive, and leave 6 at this. So we can say, okay, 6x. All right. What we're gonna do again? What we're gonna do again? We can put this as a true thing. Put it as 6 over square root of x to the power of 5. That's what this is. Minus means you put it under there. Equals this half goes over and becomes a positive half 1 over 2. And this now is really the square root of x cubed. And that's what we're solving. We want a space. And we want a space. But to get rid of the square root again, we square both sides. So this will become 36. I'm not in two lots. Most lines I'm covering so many lines, but let me move this part up a little bit higher. Here. Here. Make this small. And move this up to the solving. Make this small and zoom. All right, so that's what we're solving. So you square both sides, get rid of the square root, right? Square both sides. So you square both sides. You're gonna get rid of the square root. So it's gonna become 36 where you square it. Square side gone, so you get x to the 5th power equals. It's gonna become a 4 where you square it. Square side gone, so you're gonna get x cubed. Then out of this now, this x cubed cancel out of this and give me x squared. And see that, right? If I take this and multiply it up here, or put it another way, take this and multiply it up here, and take this for multiply it across here. Let's see what we're gonna get. We're gonna get 4 times 36 equals x to the 5th power over x cubed, which becomes x squared. This becomes x squared. And so all I have to do now is square root this. And see it's positive again, you know, it's a positive square root of 1. Look. As the graph is everything on the positive side. It's positive square root of 1. Right? So square root of this becomes 2 times 6. So it's x equals square root of the 4. Become the square root. Square root of 4 times 36. Square root of the 4 is 2. Square root of the 36 is 6. So the answer is 12. That's x value at the maximum point. But I good at that? But okay?
Yes, sir.
This the next part now says, find the area of region bounded by the curve x-axis and line x equals 9. That question nice. Find the area bounded by the find the area of the region bounded by the curve, the x-axis, and the line x equals 9. So it's like you want the area out here. So question 9. You want this area here. So that area up to 9. So between you must write this off 4 and you must write this as 4, right? But at this point was 4. At this point right here, so was 4 at E. Right here, so was 4 up to 9. So integrating between 4 and 9, equation of a curve, this curve. That's where you get the area. Integrating this area between 4 and 9, this curve between 4 and 9 to get the area. That's what I wanted to do. All right, let me write what we have to integrate up when I copy it down to get the area. So the area that I want is the integral between 4 and 9 of this curve, which is 9 brackets x to the minus half minus 4x to the minus 3 over 2 dx. Then copy this down. That's what we're gonna do to get the area. Copy this down. That is gonna use negative powers. That's what we have to do. All right, let's go. So this 9 is a multiplying constant that can come out to the front, right? So we're gonna get the area equals 9 into. We're gonna integrate this expression. So you add 1 to this power, becomes x to the half. So you're gonna get x to the half and divide by the new power per half. Minus 4 times. Add 1 to this power, we're gonna get x to the minus half. And divide by the new power of minus half. And you're doing that between 4 and 9. All right. Now, This minus and this minus can turn this into a plus. I can cross it and turn this into a plus. All right. And then now, these two are like dividing halves. They can come under here, outside here. So divide by half is multiplied by 2, so it becomes 18. So like we take them 2 here and factor the 2 of them under the 9. So like you get the 9 over the half. Divide by half is multiplied by 2. So this 9 is going to become 18. And then 2 halves that go outside. Let me simplify. So the A becomes equal to 18 into, let's simplify this now. This is just the square root of x plus, this now is 4 over the square root of x. 4 over the square root of x. Ready to plug in the values now. So A equals 18 into bracket. Plug in the 9 first. 9 into here, so give me 3. Square root of 9 is 3. Plus 9 into here, so give me 3 again. I get 4 over 3. Minus, we're going to plug in the 4 now. Plug in 4 into here, so I'm square root of 4 is 2. Plus, plug the 4 into here, so again, square root of 4 is 2 again. That becomes 4 over 2. That, when you work that out, you get the area right there. Put that in the calculator, and you get the area. I'm going to do it because of this 4 over 3. Can't bother. Let's put that in the calculator as is. And see what we get. So I'm going to write 18 times bracket, and then a bracket again. I'm going to put 3 plus 4 over 3. No, not times, Mr. Shaw, plus. All right, 4 over 3. Close that bracket. Minus another bracket. And that is just 4, but this is 2, right? That is 2. 2 and 2 is 4. So that is just subtracting 4. Close that bracket. And close that bracket. And that says 6. Here equals 6 units squared. Nice and easy. But good at that? But okay?
Yes, sir.
That paper though, jumping on the next paper now, you know. Jumping on the next paper, which was the paper I told us, pure math students. But advanced students, you know, can stay on and look to. There's some stuff on there that you can learn from as well. No maths equals better maths every time. So this is the other paper that I gave you guys to do. I think I will give you about 3 questions on this paper. But a lot of it is not on the syllabus. All right, a lot of it not on your syllabus. So I gave you this one to solve first. To solve that to 3 decimal places. This first question. I think I told you the number 1. Which you can look at. ln is just log to base e. That's what ln is. I try to find this x. All right. Remember the laws of log. Indices can look. Logs and indices are connected. So if this is log to base e of 1 plus 2 to the x equals 2, means that this number is equal to this base e raised to that power 2 to start. And e is just a constant. I can actually find e squared on the calculator. So this becomes 1 plus 2 to the x equals e squared to begin with. Better good at that? Better good with that so far?
Yes, yes.
Transpose this 1, it's going to become 2 to the x equals e squared minus 1. Then when something that you want is in the power, you want to get out of the power, you take logs. I'm going to take log to base 2 of each side to get rid of this 2. Or just log, it doesn't matter, log to base 10 or ln. You can take ln again. So we can take, since it's pure maths, log, any log you want, take same difference. We're going to get log of this side equals log of the entire side over there. Then this x comes to the front. All right, so you're gonna get x log 2 equal the log of e to the x minus 1. And this log 2 divide under here. And so now x is just equal to, put on another line is to show x now equal to the log of e to the x 1. Mute your mic, please. Divided by the log of 2.
Going
Exactly. Mute your mic, please.
over
Mike,
to
mute your mic. Oh my goodness, David,
to
man.
go. What did it say that was? It's a thing I have to like so I don't think I'm
He's talking. Alexander Richards, mute your mic. All right, so put this in the calculator and I'll get your answer. Put this in the calculator and we shall have our answer. This thing right here. So it's gonna be a fraction log. There's a log to this 10 I'm using of e to the x e. Not e to the x, no, it's e squared. Right? E to the x is e squared. See, it's e squared here, so. And e squared here, so. So from what I write in e to the x, says e squared minus 1 divided by the log to this 10 of 2. And that is 2.6756. And I'm said 3 decimal places. So that's 3 decimal places is going to be 2.67 is 5, 6, you know. So this 6 turn this 5 into a 6. So this becomes a 6. So that's 3 decimal places. That's the answer right there. Nice and easy, quick and fast. Very good. Martino, you good? Martino not answering. Now this question is for pure maths. We're not solving a modulus function, modulus inequality. We have modulus on both sides of the inequality. There is no shortcut. You have to square both sides. You have to square both sides. Square both sides to get rid of the modulus. Expand and solve. That's what you have to do. So this becomes x minus 4 squared minus 4 squared less than 2 into 3x plus 1 all squared. That's what it becomes. So expand this side becomes x squared minus 8x plus 16 less than. Square this side, we're going to get the 4 where square that 2 first. And then inside this bracket, we square this. We're going to get 9x squared minus 6x, not minus, plus 6x, and then plus 1. Expand this some more. We're going to get x squared minus 8x plus 16 less than. 4 times 9 is 36. X squared 4 times 6 is 24. X and 4 times 1 is 4. We can bring everything over onto this side, because this is the bigger side, right? So we're gonna have greater than 0. So you're gonna have 36 minus 1 is 35. So it's 35x squared. And this equal come over and add to the 24. 24 and 8 is 32. 32x. And then this 16 goes over and minus from that 4 to give me negative 12. Greater than 0. What a number. What a number this is to factorize. Oh my goodness. So it works out really to 35x squared plus 32x minus 12 and that is now greater than 0. I want to factorize that. If you can't factorize it, then you can't see. Just use a quadratic formula. Use a quadratic formula. I'll have to multiply these two in coefficient. That's too long. We can't bother. The quadratic formula and what the roots are, yeah, man. Quadratic formula to find the roots. X equal. Let's see if we do it in red. But okay, factorize the number there. Too big right now. The roots are x equal minus b, which is minus 32. Minus 32 plus or minus the square root of 32 squared minus 4 times a. The a is 35 times the c. The c is negative 12. That's space, Mr. Shaw. Times negative 12. Sorry. All over 2a. 2 times 35. That's how solving. Let's put in the calculator. Get the roots quickly. One with the plus and one with the minus fraction. Then we have minus 32 plus the square root 32 squared minus 4 times 35 times negative 12 close bracket all over 2 times 35. I'll get that funny looking number. That question we keep. Let me see what that is the exact value. You know, repeat number, so it was a fraction. Let me see what it is. The repeat value, so it was 2 over 7. So yeah, 2 over 7. So we have 2 over 7 and x equals what's the other value with a minus. Still is to a minus now. Minus 1.2 and negative value. Negative 1.2 is negative 6 over 5. Negative 6 over 5. All right, which was smaller? Put the decimal. Oh, wait, this one negative, so we're not worry about that. So we have a scatter graph for this function. It's going to be a smile for the square term positive. And the two critical values are the positive one is 2 over 7 right here. And the negative one is negative 6 over 5. And one which is greater than 0. That's up here. And up here. So you go into the right of this positive, this root, and to the left of this one. That's where your solution values lie. So the solution line is, put it in purple, solution. X is less than this negative 1. X is less than negative 6 over 5. Or x is greater than 2 over 7. 2 over 7. You know, the first factor of this I was going to try was 7 and 5. It would have worked. But I say, okay, but those are the natural factors of that I would have tried 7 and 5. But that is it. That's the solution, guys. That's the solution. But Tina, that is for you and Giovanni. Tina and Giovanni. When you get a modulus equation, cut it again. Right? With modulus on both sides of an inequality, there is no shortcut. You have to square both sides. Square both sides. Expand it out and solve it as I just did right here. There's no form result for this one. All right. Let's go again. Next question. Did I tell to this one? No. I didn't tell to this one. I'm not wicked enough. It's not on your syllabus, so you got that plan to do. I tell to this one, yes, this one is on the syllabus right here. That one is on the syllabus. It wants us to write this in this format. There is a match. They match. There is a match in every way. In this case, A is 8. The B is 15. The R is equal to the square root of A squared plus B squared. So the R come in here. This format matches that format. Because we expand this, because of the plus getting a minus here, and getting the R cos first, matching the 8. All right, so the R becomes the square root of 8 squared plus 15 squared. That's like 17. I think that's 17 and 8, 15, 17. Let's see. 8, 15, 17, Pythagorean triple. 8, 15, 17. My brain not telling me that yet, but brain telling me it's 8, 15, 17. So it's 8 squared. Let's say the square root of 8 squared plus 15 squared. 17. That's right. 8, 15, 17. Pythagorean triple. So this is 17. And the alpha is always tan to the minus 1 of the B over the A. The B over the A. These are stuff that you must know. This. You must know this. You must know that. When the form is match, they match there now. You have to know how to match the forms. You have the must know sheet that I gave your pure math students. All right. And so we just need to work this out now with the calculator. Tan to the minus 1 of B over A. And put the values. So the alpha is tan to the minus 1 of the B is 15 over the A is 8. You work that out. You're working in degrees between 0 and 90. Tan to the minus 1 of 15 over 8. That's what the calculator gives us. Calculator. Tan to the minus 1 of 15 over 8. 61.9. 61.9 degrees. That's what they tell us to do. There's a two decimal place. That's what the second decimal place is. 61.93. 61.93. Two decimal places. 61.93. 61.93 degrees. That is your alpha. Right? That is it. So you can say therefore that expression 8 cos theta minus 15 sine theta, sorry, is equivalent to R is 17 cos of theta plus alpha is 61.93 degrees. That is it. That expression is equivalent to that. Right, another form. That is it. All right, with that, so much space they give to do it, they don't need so much space. Can't penalize it for advanced knowledge. Then they say you're solving this equals 4 now. So if you're solving that equals 4, you can say, i.e., you're really solving 17 cos of theta plus 9, what is it again? 69.9, 69 point, we're not good enough, we're old. 61.93. 61.93 degrees. You say solving that equals 4. That's what you're solving. And one answer between 0 and 180. And then you want the first two quadrants only. But what we can do is find all of the angles them and then give them the angle answers that fall in that range. All right. So this means that cos of theta plus 61.93 degrees is equal to 4 over 17. So you can draw the quadrant diagram for this. Cos is positive here and there. And then the principal angle, alpha, shift it over somewhere. the principal angle in red. Principal angle alpha is going to be cos to the minus 1 of 4 over 17, broken in degrees. All right, the acute angle that we get. Cos to the minus 1 of 4 over 17 right here. So then cos to the minus 1 of 4 over 17. That's 76.4, 76.39. Let's keep to the 2 decimal place. 76.39. 76.39. That's 76.39 degrees. Now let's split the screen and keep the calculator visible. All right. All right. Then we want those two angles now. All right. So this now is equal to your principal angles. This is your angle that you're finding. So you're gonna say theta plus 61.93 degrees becomes equal to this quadrant is this value first. All right, which is 76.39. All right, and it's also equal to this quadrant, which is 360 minus 360 degrees minus this 76.39. It's not gonna work out. All right, this one is gonna be too much. We have to know one angle we're gonna get. I'm gonna subtract this over there. This one too big. Right, that one too big. If we subtract 360 from this, 360 minus, it's working out to 280 something. It's working out to 283.61 degrees. So even if you subtract this from this, it's still more than 180, right? If you go now and subtract the 61.93, it's still more than 180. So the only answer I get in is with this value. So the theta then has a valid value, valid angle between 76.39 minus 61.93 degrees. We take this and subtract it over here. Right? This one is going to put us out of the range that I want between 0 and 180. That is it. Theta equals that one angle. So it will be 76.39 minus 1.93. That's 14.46 degrees. That is the answer right there. How that look? But good? But okay?
Yes, sir. Yes.
All right. Let's go again. More maths equals better math. Did I tell you to do this one? Nope. I didn't tell you to do that one. Did I tell you to do this one? Yep. I put it to do this one. Vectors. All right. Let's look at this one now. This one gives us a line L, this format, and it gives us a plane in that format. All right. So this line here can be written as, let me write them. The line can be written as R equals, sorry, line L can be written as R equals, this is a point on the line, 1, 2, -3 plus lambda into 2 minus 1, 1. 2 minus 1, 1. Remember, this is a point on the line. This is the direction component of the line. This can be written as a point, and you're basically adding up everything. So it will be 1 plus 2 lambda, and 2 minus, this time it's going to be lambda, and minus 3 plus lambda, minus 3 plus lambda. So the line can be written as a point like that. That's a line. And then the plane now, the plane P, this plane can be written as the X, Y, and Z is your R. And then the coefficients now, the 3, 1, 5, 3, 1, -5 would be the normality of plane. So it can be written as X, Y, Z dot 3, 1, -5. Just identify the components. 3, 1, -5 equals 20. So on the line, on the plane, this is your normal to the plane. And this represents a general point R on the plane, right? All right, so the question says, show that the line lies in the plane. That's quite simple. If the line is on the plane, then it simply means that 2 points on the line also is on the plane. And if a point is on the plane, it means that it satisfies the equation of the plane. So this is already 1 point on the line. And to find another point on the line, we can give the lambda a value of 1, for example. Right? To find another point on the line. So points on the line. Points on the line. Points. When the lambda equals 0, you get in this point. So a point on the line is 1, 2, minus 3. That's the portion vector of a point on the line. And when the lambda equals 1, put it in here, put it in here. Right? Another point on the line. When this is 1, you get 1 plus 2 is 3. You get 2 minus 1 right here. 2 minus 1 is 1. And then you get minus 3 plus 1 is negative 2. So these are 2 points on the line. If the line is on the plane, then these 2 points satisfy this equation. In other words, when I do the scalar product on these points here, it must equal 20. All right, so I'm going to test them on the plane. All right, so test 1, 2, minus 3 on the plane. So you're going to have 1, 2, minus 3 dot this 3, 1, minus 5. Now, if this work out to be 20, then it's yes, it is on the plane, the truth. Let's test it. So 1 times 3 is 3. 2 times 1 is 2. And then minus 3 times minus 5 is a positive 15. That add up to 20. So yes, correct. That is on that pass the test. Scalar product is 20. If this point is on the plane, then again, it satisfies the equation. That's all you know when a point is on a plane. It satisfies the equation of a plane. So we want to notice the other point. That's our point on the line, which is 3, 1, negative 2. So if a line is on a plane, then any 2 points on the line also on the plane. Once you get 2 points on the line, 2 different points on the line that satisfy the equation of the plane, then it means that the line is on the plane. So we're using this point now as your x, y, z right here. So it's 3, 1, negative 2, scalar product with the normal here. So 3, 1, negative 5, and then see if this works out to be 20. So it's 3, 3 is 9, then 1 times 1 is 1, and then 2 times 5, negative 2 times negative 5 is a positive 10. And that equals 20 as well. So yes. And that therefore that is it. Since 2 points on the line are also on the plane, then it means that the line is on the plane. That is it. If you want to write a statement, you can. That is it. But to go to that, 2 different points on the line is also on the plane. So the line itself is on the plane. But good? Understand that, Giovanni? Giovanni. Giovanni Hepburn.
Yes, sir.
You understand that?
Yes, sir. I understand.
Next part. Let's see if you understand the next part. It says a second plane is parallel to L. So a second plane parallel to L and perpendicular to P and contains this point. And it says find the equation of this plane given it in this format. All right. So a second plane is parallel to L. Let's see if we can do like a schematic, right? So like you have a second plane, you have a plane like this, right? That we're trying to find. So that plane is parallel to L, all right? So let me draw L up here. So this is L, I've had before. This is the line L. Let me shift it over to more to the middle. Sometimes you can actually visualize it, you know, it's kind of easy to explain. So we're trying to find this plane. That's an unknown plane, right? And that plane is parallel to L. Now remember, the direction of this line becomes important. The direction of this line, L, is this. Here is it. Here is it. Is this. 2 minus 1, 1. The direction of that line is 2 minus 1, 1. And put it down here. So 2 minus 1, 1 is the direction of that line. And this is the plane that we're trying to find. Right? We'll put it so. Let's call this plane F. Let's call it. So we're trying to find F. Now this plane F is perpendicular to the first plane P. So I'm going to draw the first plane P this way. Right in blue. Let's draw it like this. This is the first plane that we had. Then perpendicular, right? So this plane is P. Not exactly quite like this. It's a good schematic to show it. Now, what do we know about plane P? We know the normal to plane P. We can put it in here. We know the normal to plane P. This is the normal to plane P. See, perpendicular to it. All right, we'll put the plane that we want in a different color. It's kind of easy. So let's say we're trying to find this plane, this red plane, plane F. All right, so this is the normal now to plane P, which we know the normal to plane P. They put call it NP is the normal to plane P. We know it is this 3, 1 minus 5, 3, 1, negative 5. So that direction is perpendicular to plane P. So to find the equation of this plane, I'm telling you, it pass through that point here. So that already give us a point on this plane. Let's put it on. So they give us a point on this plane. Let's put it right here. That point is 3 minus 1, 2. That's a point on the plane, right? That's a portion of the point. So that's a point on the plane. So to find this plane now, what we need to find is a normal to it. We need to find a normal to the plane. Because if you have a normal to this plane, let's call it capital N. Let me draw it all the way up here. So let me draw it all the way up here. This normal to this plane. Let me draw it all the way up here. So trying to find this normal to this plane. Capital N. I'm going to call it A, B, C. Set the values on it is A, B, and C. We don't know. We don't know those values. But we know that the normal to this plane right now is perpendicular to B. Know that, see that? It's perpendicular to B. Even if that diagram, you can see it. It's also perpendicular to N. This NP, don't have to say perpendicular to it as well. So the normal that we want is perpendicular to this and perpendicular to that. Trouble is, we cannot get two equations. You can get an equation from the fact that these two perpendicular, that's one equation. You can get another equation by the fact that these two perpendicular, because perpendicular vectors, scalar product is 0. All right. But we have 3 unknowns, 1, 2, 3. But in vectors, that's not a problem, because all you need to do now is express 2 of them in terms of 1. All right, because we're trying to find any normal to this plane that we're trying to find, any normal. So once you find a normal that you know the values, with this point, you can get the equation. So like we're trying to find those values A, B, and C. We're trying to find this normal up here. So what do we know? We know that this normal perpendicular to this to begin with. Let me write it in red. So we know that the N is perpendicular to B. So once the N is perpendicular to B, the scalar product N dot B is equal to 0. So we're doing the scalar product between this and put it equal to 0. So A times 2 is 2A. So we can say therefore 2A, then B times this minus 1 is minus B. And then C times this 1 is plus C. That is equal to 0. It's a scalar product. We also know that the N is perpendicular to the first normal. So we can write that as well. N is perpendicular to the normal of P. What does that mean? It means that that N that we're trying to find on the scalar product with it and the normal of P is equal to 0. Which implies now, when we get the second equation, scalar product between this and this now. It is the a times 3, that is 3a. And then the b times 1 is b, that's a plus b. And then the c times -5 is -5c, and that's equal to 0. And so we have these two equations here. Put them in a box. Put them in a purple box. We have these two equations. Equation 1 and equation 2. That would have liked to try and solve. The problem is we have 3 unknowns. As I said, no problem. We're gonna find a way to express 2 of the unknowns in terms of 1, and that will help us to find a new normal. All right. So what we're gonna do, we're gonna express all of them in terms of a. All right, we're gonna express all of them in terms of a. So I'll express the b in terms of a and express the c in terms of a. Express everything in terms of a. So the first thing we're gonna do, we're gonna eliminate the b first from the 2 equations and express c in terms of a. So see it here. We're gonna eliminate the b from the 2 equations and then express c in terms of a. That's the first thing. I've learned these methods in the guys, I'm gonna show them in class. So to eliminate the b from these 2 equations, we just need to add them because we have a minus b and a plus b here. So to eliminate the b, we just need to add the 2 equations, 1 plus 2. And we're adding 2 equations. So we'll add them, 3a and the 2a give us 5a right there. So, and this gives us minus 4c. This c and this minus 5c gives us minus 4c. And then we add them 2 things, you know, you're getting 0. So you have to write c in terms of a, making c the subject right here. So if you look at this now, we can transpose a c here and then divide by the 4. So you can see that the c is equal to 5 over 4a. That's what the c equal to. Then you want to eliminate the c next and express b in terms of a. So the next thing, eliminate the c. So how do I eliminate the c from these 2 equations? I'm going to have to multiply this first equation by 5 so that this becomes a 5c, and then add it to the second equation. All right, so focus now. So I'm going to do 5 times equation 1. That's what this means. 5 times equation 1 plus equation 2. So we'll concentrate now. So it's going to be the 5 times this 2a. 5 times 2a is 10a plus 3a. That makes it 13a. So I'm getting 13a. I'm going to do 5 times this minus b is minus 5b. Minus 5b plus this b give me minus 4b. Right? Minus 4b. And then 5 times this c give me 5c. And you add it to minus 5c. So the c gone. And then 5 times 0 is 0 plus 0 is still 0. So this equals 0. And so from this equation now, again, remember, I want to make b the subject. So I want to carry this over again and divide by the 4. So you're going to get that the b is equal to 13 over 4a. Now, with these 2 values now, we're going to plug them back on the end. Right? I'm going to plug them back on the end. So watch me carefully now. But the end is a, b, c up here. So my normal, so we're going to say, therefore, the normal that I'm trying to find becomes a. The b is 13 over 4a. 13 over 4a. And the c is 5 over 4a. 5 over 4a. That is my normal. Which means I give us to finish here. So I'm working doing the question last, no problem. Then what to do here, so now you're trying to get a known vector out of this. So I want to be factorizing out my a. I don't want all these fractions. You know what I'm going to do with this A? I'm going to put it as 4 over 4A. All right, I'm going to put this as 4 over 4A, this original A up here. So back in red. Make everything have a same denominator so I can want to get some whole numbers. I'm going to put this original A as 4 over 4A. 4 over 4. Just undo. And 4 over 4A. Then I can factorize out A over 4, A over 4, A over 4. I'll factorize out a quarter A from this. This becomes equal to a quarter A into, this becomes 4, this becomes 13, and this becomes 5. And therefore, this now becomes a known normal to the plane. Remember, means that this vector is now, means that this vector is parallel to my n now, as I've expressed n as a multiple of a vector. So it means that this vector is parallel to the n that I was trying to find. So it means that this vector is also perpendicular to the plane. So I'm going to use this now as the normal to the plane that I want. So it means that my normal to the plane, go back to blue now. It means that the normal to the plane that I'm going to use, normal to the new plane. Call it F, call it, no, why did I call it F? Final plane, I don't know why I call it F. Anyway, the normal to F that I'm going to use now is 4, 13, 5. That's the normal I'm going to use. And then the equation of the plane now, remember the equation of a plane is R dot N equals A dot N. Right? And the N I'm using is NF. 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 And this is the A. The A is the point that they gave us on the plane. I don't know what this A is, this point right here. So it's 3 minus 1, 2. That is the known plane, the known point on the plane. I'm going to work it down here without all the space. I'm going to work it with this little box right here. So because I want the answer in XYZ format right here, we're going to make the R be XYZ in this form, in this formula. Let this R be XYZ. So I'm going to be XYZ dot the normal that we know, the known normal, which is this, which is 4, 13, 5. 4, 13, 5 is not equal to the A up here. What is it again? The known point that they gave us is 3 minus 1, 2. 3 minus 1, 2. 3 minus 1, 2. Dot the normal again, which is 4, 13, 5. I just need to work out this scalar product to get the D. Work this out and get the D. So we can work this out. This is 3 times 4 is 12. Minus 1 times 13 is minus 13. And 2 times 5 is 10. And this basically works out to 9. This is negative 1 plus 10 is 9. So basically doing this equals 9 now. Right? And so this number becomes 4 times x is 4x. Y times 13 is 13y. 5 times z is 5z. And that's all equal to 9. And this right here is your answer. Equation of that up here. Very good. I'm gonna send this video and watch it over. And this is 3-1, 13-1. Are you okay with that? I think that's the last question I told you to do. You are good with that?
Yes, sir.
All right. So I tell you to do this question, you know. You are told to do this question because that's a rate of change question. Integration. I'm gonna do it for you. I'm gonna call it a 9. All right. I'm gonna do that question for you. But I didn't tell you to do that. When I look back at the paper, I should have told you to do that question. You can get a question like that. This one don't know. I don't know. This one we can get. this time like this. So, formation of differential equation. So it gives us this water tank. It says a water tank has vertical sides and horizontal rectangular base as shown in the diagram. The area of the base is 2 meters squared. So the area of the base is not going to change. The area down here is 2 meters squared, right? Area of the base is a constant 2 meters squared. So the volume right here, remember volume is cross-section area times height. And so the volume becomes 2H. That becomes the volume of liquid in it, 2H at all times. But this is the cross-sectional area. Remember, volume is cross-sectional area times height. And the area is that. So it is 2H. So I'm going to shift these around, right? That becomes the volume right here. Man, what you doing, man? I'm going to go more. So the area of the base is 2 meters squared. The volume becomes 2 times H. All right? 2 times H. And it's changing. So it means that the rate of change of the volume with respect to the height is equal to 2. So we differentiate this by 2. That's one rate of change, the volume with respect to the height. Right? It says at t equals 0, the tank is empty. So when t equals 0, the volume is empty. The volume is 0. So you know that when t equals 0, that's what this statement means. The tank is empty. So when t equals 0, H equals 0, t equals 0, H equals 0, and the V equals 0. All right? You know that when t equals 0. So that's like a starting point to find a constant of integration if you have to, if you need it. It says that water begins to flow into it at a rate of 1 meter cube per hour. All right, that's water going into the tank at 1 meter cube per hour. So water is adding. That's a dV by dt. They're just telling you dV by dt into the tank. Then it says now at the same time, water begins to flow out of the base at a rate of 0.2 times the square root of 8 meters per second. This again is a rate of change, but it's coming out. So you have a net rate of change. All right. So based on that, those two statements, dV by dt is equal to 1 going in minus this amount coming out, 0.2 times the square root of h. So this going in and this coming out. So this is the net rate of change of the volume with respect to time. All right. Where h is the depth of water in the tank at time t hours. It says form a differential equation satisfied by h and t. We want it satisfied by h and t. So that's not what I want. So I want a differential equation with h and t. And then show that that time t hours, and show that the time t hours taken for the depth of water to reach 4 meters is given by this. So this is when the height reaches 4 meters. All right. All right. So basically, this is what we have. So we have this differential equation right here. It's a differential equation. This constant. And we also have this one. Information. What this wants us to find, is dH by dt. That's what it's asking. See, h and t. So one h and t. So we set up that rate of change. We're going to have to connect the ones that we have. dH by dt equals, again, the product of 2 rates of change. dH goes on top of the first one right here. dt goes on the bottom of the second one over here. And the third thing that's changed is the volume. So dV goes here and dV goes here. Now we're on a problem because this one comes from up here. You see it here? If dV by dH is 2, then this is dH by dV, the reciprocal. So this is equal to half. And then this now is just this right here. All right, so this then I can write it over here, so it becomes equal to half, that's the half, times, and then this now is this. Half times bracket 1 minus 0.2 root h. All right, that's what we get. But then now they want us to solve and get time equals that. So let's finalize this differential equation now. And I said I'm about 10 and a 5 here. So I said I'm now on the decimal. And this decimal is 2 over 10, which is 1 over 5. It's possible that's how them get this 10 and 5 here. So I'm going to write it that way. All right. So I'm going to write dh by dt equals, put this as one fraction. All right. So this now, this 0.5, this 0.2 becomes 0.1 and a half it. I put the two of them over 2. All right, you know what? Because of this, I'm gonna write this as 1 over 5. All right. I'll put this as 1 over 5. So I'm gonna write this as 1 over 2 times 1 minus 1 over 5. This is 1 over 5, which is root h over 5. Put as one fraction. Put this 1 as 5 over 5. Now put this as one fraction. I'll put this as 5 up here. So that's what it becomes. So multiply this under here, so now we get the 10 that I have right here. Beautiful. So it actually becomes equal to 5 minus root h over 10. Oh, that is it. dh by dt. That's the differential equation that we have. All right. Then now, if we want to solve it by separating the variables, then what we have to do is multiply this 10 up here, and take this and divide it under, put them over here with the dh, and then put this dt over this side, like so. Cross multiply. So we're going to get 10 over 5 minus root h dh, the dh equals, and the dt alone over here, so now dt. Aha, that is it. That's what we have, right? Watch this now. What we're gonna do now to get what they have here is to integrate both sides. We're gonna integrate both sides. So we're gonna integrate this side, integrate this side. Now, on this side, remember we say we're going from 0 to 4. Because them say them want to know when it go up to 4 meters. So you can height from 0 to 4 meters. And the time that this side is going to take is when the height was 0, the time was 0. So it's going from 0. And the time that it reached 4, they tell us is t. So they said, you know, it's t. They say that this integral is actually going to work out. This side of it is actually going to work out to integral of 1 dt is t between capital T and 0. Where this then just simply becomes t. Right? So this thing now just becomes t. So you see, you get what they said. T equals this. Just add that over letter space. So I'm doing that. I've shown it. T equals that. That is it. Shown. Understand that, guys? Your
Yes, sir.
Of like this and that. Then them say no. Using a substitution, u equals this. We must find the value of t. In other words, t equal an integral here. No? They want us to do this integral using a substitution. U equals that. So let's write it out. The t is equal to the integral from 0 to 4 of 10 over 5 minus root h dh. And I want us to work out what this is. by making a substitution. U equals 5 minus root h. Let's set it up. All right, so if u equal 5 minus root h, we change the variable to u. These are h values. So we're going to have to change these values to u values. We're going to do it with this equation right here, right now. Change those limit values. Firstly, when the h equals 0 down here, so the u is going to become 5. And if you put 0 here, so you're going to get u equals 5. And up here, so where the h equals 4, the u is going to become, when you put 4 here, so you're going to become 5 minus square root of 4 is 2, you're going to get 3. So the u is going to be 3. It's going to be 3. So this limit going to become 5 and this limit going to become 3. Don't worry about it. It's going to work out itself, right? So negative going to come into play, must come into play somewhere. As the first thing, we change the limits. So I've dealt with the limits. Then now we're going to have to change this dh. All right. And remember, we're going to replace this with a u. All right. We'll have to change this dh. To change that dh, we have to differentiate this. So when you differentiate the u, you get du. We differentiate the 5, we get 0. And we differentiate this. This is really h to the half, minus h to the half. That's what it is. So we differentiate it. We're going to get minus half h to the minus half dh. That's what we're going to get. dh. So that's all we're going to have to try and substitute for the dh right here now. So we can do that now by making this dh a subject. So we can substitute for it up there. All right, make this dh a subject. Let us simplify this now. So we're going to simplify this expression and write it as du equals, put this as minus 1 over the square root of h. This 2 on here as well, 2 dh. So then we can see what dh is by multiplying this up here and put the negative as well. So the dh is just minus 2 root h du. 2 root h du. Well, we're going to have to substitute for this root h now, right here. Remember, I know we're making u, write everything in terms of u. So based on this, the root h, if we make this a subject, it will become 5 minus u, we put in a different color. Okay, I take this and carry it away, it become positive, and take this and carry it away, it become negative. So you know right away that root h is actually 5 minus u from this. So this root h is 5 minus u. So want everything in terms of h, so this becomes minus 2 into 5 minus u du. That's what the dh is equal to. So we have everything we need to substitute now. 5 minus u du. So based on that now, you see, we can substitute into this. All right, and put it on the side here. So this now becomes, t now becomes equal to the integral. Watch this now, The 0 becomes 5. For changing everything now, 0 becomes 5. The 4 becomes 3. This is 10. That stays as a 10 over. This 5 minus root h becomes u from this substitution right here. So it becomes u times this du, this dh, sorry, this dh becomes this expression right here, which is minus 2. Okay, we can expand this, for one thing, and just put it as, make it stay. minus 2 bracket 5 minus u du. That's what we have. Let's simplify this now. So t equals, watch this now. Take that minus and bring it out here. You know why? Because I want to reverse them limits there. I'm going to put the minus out there. So integral, or I can drop the minus same time, drop this minus and reverse these two integrals. Because a minus in front of an integral between limits means that you can drop the minus and reverse those limits. So I'm going to drop this minus and reverse the limits. Hope you understand that. So this becomes integral from 3 to 5. The minus are gone, you know. All right. Then we're going to come to now, boom, and multiply this 10 times 2 is 20. Right? So I'm going to get 20 into 5 minus u over this u du. When we come to this now, it's something that you guys can integrate. Because this 20 can come out here as a multiplying constant now, It's a t equals 20 integral from 3 to 5. And like you have 5 minus u over u. So you have the 5 over u minus, and then u divided by u is 1 du. That's what the integrating. But the integral of 5 over u is ln u, guys. ln u. But I don't think that integral is on the syllabus for pure maths. But this becomes 5 ln u, and then this becomes u. So t equals 20 into, this becomes 5 ln u. We integrate 1 over u. We integrate 1 over u, it becomes ln u. With respect to, if you integrate 1 over x, it becomes ln x. So this becomes 5 ln u minus, we integrate this 1, you get u. And this is going between 5 and 3. That's how we're going to get the value now. Because the t then is going to be 20 into, plug in the 5 first. We'll get 5 ln 5 minus 5 in the first bracket, minus, plug in the 3 next, we're going to get 5 ln 3 minus 3, second bracket. I'm going to put everything in the calculator right there, so I'm going to get t, and time is in hours. And then we're going to put down. Right on the calculator here. Let's put that in the calculator, and we are du and done. 20 bracket again. 5 ln 5 minus 5 close brackets minus 4 bracket 5 ln 3 from here minus 3 close that bracket 11.08. What decimal point instead of one? Find a value of t. 11.08. T is 11.08 or 11.1. Treating figures. 11.1. So that value, because the thing said t hours. So t just a value. Where is it? T? Question said t hours. Where you going, question? Right, question said t hours right here. So t is just a value. You don't put a unit on the t. T is just 1.0, 1.1, 11.1. Sorry. Beautiful custom, beautiful. Beautiful. Yes. But God, even if you couldn't down here, so I'd solve this part down here, so, right? Because you don't learn to integrate like 1 over x. The ln x. I think I'm gonna maybe give you guys one day, show you that those integrals. And you should be able to formulate the differential equation still, and do that part up to here. Right? And when you make the substitution, you're supposed to understand how you change the variables, the processes that went through to change the variables, to end up with something like this. At least Tony, you should be able to reach. All right, you have to understand the process. It's just the integral of this particular expression. It's questionable for your syllabus. All right, and a special kind of fraction. But that is it, guys. We've been going for a while now. Oh, by the way, I will be able to have class on Friday. I have a funeral on Friday. But what I do is send you some work. But I won't be able to have class on Friday. Sorry to be postponing so many of the Sunday class, your Friday classes. That's also it is something things just keep popping up on the Fridays. But we're gonna make up. I would always say we're gonna make it up. We're gonna make it up all. Right? We're gonna binge it. All right, everybody. I always say I'm gonna share this video with you afterwards. So there's some add material, some pure material in the session. I'm gonna send you another set of papers like these for you to practice for Friday. And then we'll come back with and work through again. All right, everybody. So that is it for today. Okay.
Yes, sir.
Yes, sir.
All right, bye-bye. Cool. I'm gonna end it now.